Now we want to start talking about actually describing matter. And I'm going to start by classifying the types of matter. We're going to look at substances. When describing matter, the place we always want to start is going to be the phases of matter. We know that matter, we can have solids, liquids, and gases. And any type of chemical that we're looking at can be in any of these three phases. So for example, you could have liquid water, you could have solid ice, or you could have gas steam. And we know that solids, liquids, and gases have consistent properties or characteristics. Solids, definite shape, definite volume, right? They hold their shape. Liquids don't hold their shape, but they do hold their volume, whereas gases have nothing definite. They can change their shape based on their container. They change the volume based on whatever container they're in. And so these sorts of classifications of properties that we can see that by defining what a solid, a liquid, and a gas is, it allows us to make predictions and understand the properties of something just by knowing it's a solid. So we want to continue with this and look at other ways that we can classify matter beyond that. And so these ideas of phases of matter, we know really can apply to anything. So this is bromine. We can have bromine solid, liquid, or gas. And having those sorts of classifications are really useful. We can see the properties of bromine. Liquids have surfaces. Gases don't have surfaces. Solids have shapes. So those sorts of things that we can start to make predictions about. The classifications of matter that we want to now talk about are based on the complexity of the matter. So all matter, the simplest form of matter is elements. So elements are what we say simplest is that you can't separate an element into component, basically types of matter. So there are 118 total elements. 24 are in your body right now doing things. So water is like a chemical that we interact with regularly. And water can be separated. So here you have a sample of water. If you run current through it, just with any good old battery, you can break down water into components. You can break it down into hydrogen and oxygen, two gases. And so you can break it down into its two components. And so you're separating out. So that means water is not fully simplified. Elements are the simplest forms of matter. If you had a sample of, say, this hydrogen gas here, you cannot break that down into any more simple. So that's what means hydrogen is an element, whereas water isn't because you can break the water down. We want to then look into what exactly these elements are. And so we're going to introduce the idea of atoms. So matter is made of small particles called atoms. We'll get more into this in the next, as we move forward, chapter 2. But for now, we're definitely going to say that matter is made of small particles called atoms. And each type of atom corresponds to an element. So we have, whenever we kind of zoom, if we zoom in on any sample of matter, we would eventually find some sort of smallest object. And so when we talk about separating out substance, separating out matter, or that kind of idea, what we're doing is talking about basically moving apart these atoms. When we're talking about separating, we're taking a sample and breaking it up into its parts. What is it made out of? And you can't break apart an element because it is these smallest little bits. These small little bits are the smallest part of matter. And so that's why elements can't be simplified anymore, because they are atoms. They can't be broken down in any further way and still have matter come out the other end, or once you break it apart. And so these types of atoms, these elements, have unique and consistent properties. So this example where we have copper in the solid, and then oxygen is a gas up here, and you can see that oxygen has properties that will always be the same. We can take those atoms and combine them together to make what we call compounds. And so compounds are when we take those atoms, we bring them together. So we can have, say, copper was an element, oxygen was an element. We can combine them into what's called copper 2 oxide. Okay, so now we have a new sample of matter with new properties that is a combination of different elements. So we could certainly see that it would be possible to take this sample of matter and break it apart to simplify it into those two component elements. It would just basically be unmixing the red circles and the copper colored circles. But we couldn't do that if it was just an element. Collectively, elements and compounds are then known as pure substances. Pure substances are defined as having definite and constant composition. What that means is composition means how it's made. So definite means they always have the same makeup. So for example, if you want to create water, you will need to combine the elements, hydrogen and oxygen, at a certain ratio. And that ratio will always be constant. It's always the same and it doesn't change with time. If you have, say, a glass of water and you let it sit for 1,000 years, it will still contain the elements hydrogen and oxygen at the same ratio. It does not change over time. Similarly, substances have distinct and consistent properties. Consistent, again, means that the properties of water, the aspects of a sample of water are always the same. It doesn't matter if you make that water in Baytown, or you make it in Paris, or you make it in Australia, or the moon. It is always going to have the same properties and respond in the same way to its environment. They are also going to be distinct. Water isn't like other substances. Water is water. Salt is salt. They have unique kind of makeups, unique properties. They respond in different ways to their surroundings, and they're always going to be that same kind of way. So the difference between elements and compounds then is that elements cannot be separated, right? Elements are the fundamental block that they are, right? They're the fundamental type of matter. They can't be simplified. They can't be separated into some more simple component. Whereas, so for example, oxygen is an element, carbon, which makes a diamond, is an element. Water and salt are compounds because they can be chemically separated into their elements. Water is made of hydrogen and oxygen. Table salt is made of sodium and chlorine. So you can break them apart into those elements, and that process is called chemical separation. It may not be easy, but you can still do it. Right? Water, if you run a current through it, breaking apart salt is much more difficult, but you just need a ton more current as opposed to just a simple household battery in order to break that apart into, say, its component elements. But it is possible, which is important. You can't break oxygen into anything else. It just is oxygen because those are oxygen atoms. Salt is sodium atoms and chlorine atoms. You can separate those. Making some good progress through chapter 1, our little kind of start here in chapter 1. No participation here, but we still got one more video. I'll see you there.